Today, we're going to review for our final exam. And so make sure that you really understand this. And if you don't understand it, uh, contact me through the Remind app. Remember that the class code is B as in boy, F, the number 8, the number 8, K6. That's the class code for the Remind app if you have any questions on this video. Or you can email me. So here we have the first question where they give us 2 points, segment AB, and we're supposed to determine the length of A prime, B prime. Well, the image after the dilation, of course, is going to be A prime, B prime. We have a center of 0, 0, and we have a scale factor of a half. So that's 0, 0, and the dilation scale factor is a half. So remember that if our center is 0, 0, all we have to do is multiply our points by the scale factor. In this case, our scale factor is a half, so let's multiply this by a half and multiply this by a half. Well, simple enough. 1/2 times 2 gives me A prime here. I'll get 1. And then 1/2 times 3, doing that in your calculator, gives you 1.5. Okay, well, moving on to the other side, we end up with B prime. And so we do 5 times a half, and that gives us 2.5. Okay? And then similarly, we do a half times -1. That gives us -1/2. Simple enough, right? So now it's asking us to find the length of A prime, B prime. Okay? So you could potentially take this graph down here and plot your points, A prime, B prime. So I'll do that. Okay, so I have 1 on the x-axis and 1.5 on the y-axis. So I'll put 1.5 here. And then we have, we'll call this A prime. We'll have B prime, which is 2.5 negative a half. So 2.5, we go 1, 2, 0.5 is in the middle, and go down a half. That puts us right there. Connecting these two segments gives us A prime, B prime. Okay? Now, how do I find the length of a diagonal? This is actually simpler than you might think. Remember, all I have to do here is create a right triangle in order to use the Pythagorean theorem. Okay? And we have a right angle up here. Right? So anytime you want to find the length of something, just use the Pythagorean theorem, right? So this is one way to do it. But the other way to do it is simply to find the length of AB, which is much easier, right? It's much easier to find the length of AB. So let's find the length of AB, right? Let's plot those points instead and then do what, right? Because these points are not exactly on corners. They're not like this, right? So let's not do that, right? Let's take and let's graph A and let's graph B. A is 2, 3. 1, 2, 1, 2, 3. Here's 2, 3. A. Let's graph B. B is 5, -1. 1, 2, 3, 4, 5, -1. Okay, well, here is that segment AB. Draw my right triangle. This is much easier, right? Count. How much is this side? Let's call this, right? We'll say 1, 2, 3. This is 3. This is 4, correct? And so now we say, okay, well, how much is AB? Simple. So we have 3 squared plus 4 squared is equal to c squared. Doing this, we get 9 plus 16 is equal to c squared. How do I get rid of a square root? Just square root both sides. There we go. C is equal to the square root of 25. And we know that this is actually equal to 5. So C is 5, right? So that means that this piece is 5. Well, if that piece is 5, how do I know what A prime B prime is? Well, since my scale factor is going to be a half, all I have to do is 5 times 1/2, and that gives me 5 over 2, which is 2.5. That is the length of AB, okay? So if you will, in words, you would write that the length of AB is 2.5. In this question, we're looking at a triangle and it has two parallel lines, okay? So note here, this is the important piece. It's giving us a ratio, and we're asked to find the length of DE. In order to find the length of DE, I'm going to need to know the length of AC. Well, they gave us the length of AC. It's here. Okay? In order to set this ratio, which is going to be AB over BD is equal to, right? It's equal to, that's big over small. So I'm going to do big again over the small side, DE. Okay? And so, but I don't know what the length of AB is. I don't know what the length of that is. I need to know it. In order to know this whole length, I have to figure out what the length of AD is. This is the way I figure out the length of AD, okay? So take this and let's solve for AD. 3 over 5 is equal to AD over DB. Well, DB is 6.3, okay? When you cross multiply here, you end up with AD equals 3.78. Now let's substitute in here. AB, now I know what the length of AB is. The length of the whole thing is 10.08. Right? 10.08 over BD, which is 6.3, is equal to AC, which is 9.4, all over DE. Cross multiply one more time, right? And so we end up with DE equals 5.89, which if you round that, you end up with 5.9. Let's look at number 7. A lot of us know how to set up number 7, but then we get stuck after we try to figure this out. So again, BD is 4. BD is 4. This piece is x minus 6. And we have that CD is x. Okay, remember that the rule is always the altitude. This is the altitude, which is just another word for perpendicular. Okay, that's the altitude. And it creates two right angles. So, simple. We have that 4 squared is equal to x minus 6 times x. Okay? Well, then 16 is equal to x squared minus 6x. Taking this back from algebra, this is all from algebra, okay? So minus 16 on both sides. This piece goes to 0. This piece goes to x squared minus 6x minus 16. And now we have to factor. Remember, factoring looks like this. If you don't know how to factor, go back and look on YouTube on how to factor. Okay, I'm thinking of numbers that multiply to negative 16 and subtract to negative 6. And so 4 times 4 multiplies to 16, but they do not subtract to negative 6. However, 8 and 2 multiply to 16 and subtract to negative 6. In order to get a negative 16, I need one of these two to be positive and the other one to be a negative. Okay? In order to subtract them, I need a negative 6. That means this needs to be negative and this needs to be positive. In order to get x squared, I need an x and an x. Okay? This is, however, always equal to 0. Two things that are multiplying to equal 0, well, one of them has to be 0, or both of them has to be 0. In order to get 0 here, x needs to be negative 2 and x to be 8. So the one that works here is 8, which is right here, because you cannot have a side length that measures negative 2, right? You cannot have a side length that measures negative 2. Let's look at 18. 18 is asking us to show which one is a right triangle. Which one is true to make it a right triangle? Well, for example, if you were to try number 1, and LM is 13, and KN is 6, right? If you were to try this, you got to set up a ratio that works. Well, if this is true that KN is 6, then this means that this piece is 10, right? Okay. Well, using a big triangle, we have a long side and we have the hypotenuse. Okay, so the long side, it would be long over height, right? And so this means that we have 13 over 16 is the same as, right, another long over height. Okay, so in this triangle, now, if we're focusing in this piece right here, we have that the height is 13, which is going to go on the bottom, and the long side is 10. Well, is this true that 13 over 16 is the same thing as 10 over 13? Well, let's see. Cross multiply. 13 times 13 is going to be 169 when you cross multiply. And we have 16 times 10. Well, that's 160. Is this true? Of course not. That is not true. So, number 1 doesn't work. Okay? Oh, try number 2. Number 2 says LM is 12 and NM is 9. NM is 9. If NM is 9, then that means that KN is 7, because 7 plus 9 is 16, right? Sticking with our long over height, right? Sticking with the same exact ratio, because we don't have any new sides here, we're going to stay with long is going to be 12 in the big triangle, and the height of the big triangle is 16. Now, going back to this triangle here, we have that our height is 12 and our long side is 9. And so 12 times 12 is 144, and 16 times 9 is also 144. This is true. So that gives us 2, right? This makes triangle KLM a right triangle. Let's go to number 9. Number 9 says, which statement is correct? Well, let's start with statement number one. Statement number one says that these two triangles are similar by angle. However, I only see one pair of angles being congruent and not two. That's not true. Let's try number two. Side angle side. Well, I do see two pairs of sides and one angle, but let's see if the two sides are going to be proportional. Okay, I know that 18 over 45, that should be the same thing as 15 over 36. Is this true that 18 over 45 is the same thing as 15 over 36? Well, you could cross multiply here, or you could just divide. So let's do 18 times 36. That's 648. Is that the same thing as 45 times 15? That's 675. Boom, that is not true, right? Well, it's not true because the scale factor over here is 3 if you divide it, and the scale factor on the other side is 18 divided by 45, which gives us 0.4. Of course, this is not true, right? So we just found out that that's not true. And do we have three sides here to conclude side, side, side? No, we do not. So this leaves us with these two triangles not being similar. These two triangles are not similar, and make sure that you contact me if you have any questions. What's up?
Sorry, I didn't disturb.
Nah, you're good.
Oh, it's awesome. Is that for your YouTube thing?
Yeah.